Good morning, everyone. So my name is Rajdeep, and today's session is about force.com REST APIs. We are going to cover three languages: Scala, Java, and Python. So you can reach me at the email which is listed on the slide, and you can also reach me on Twitter. Before we start the presentation, I would like to spend like a few seconds about this slide. So it's like a forward-looking statement saying that whatever I say in this presentation, don't use it to make any buying decision. And it's a developer-centric presentation, so I'm assuming all of you know that. So what is the agenda? What are we going to cover in next 30 minutes? We'll start with defining REST, try to understand what REST is, where it comes from. We'll compare REST with SOAP and what are the similarities and differences. We'll spend few minutes on REST APIs and what Salesforce platform is exposing. And then we'll look at OAuth flow, and then we'll go into language-specific implementations. So why do you really need APIs? See, in today's world, it's a very connected world. Any enterprise which uses Salesforce, Salesforce is not sitting on an island, right? So data has to go into Salesforce, it has to come out of Salesforce, right? And integrate with other systems. The other systems could be ERPs, it could be custom applications, it could be data which you have to expose on the web. Now, how do you do that? That is where the APIs come into picture. So when we exposed Salesforce platform to the developers, we started off with SOAP APIs. But as the move world towards the lighter weight REST APIs, and we started supporting that. So this presentation is about REST APIs and less about SOAP APIs. So what does REST really stand for? So REST stands for Representational State Transfer. So there was a guy called Roy Fielding. So REST in an informal way has been around as long as HTTP has been around. But this guy, he had a PhD thesis on this particular topic. So what he was saying was, what does REST really mean? It means a network of pages where the user progresses from one page to another using URIs. So a transition is happening between these pages, and they are linked together. So there are links, there are states, and then there is a state transfer from one page to another. And that is what REST is all about. And the most important thing to remember is REST is a very, very informal I would say definition. It's not a protocol in itself, it just overrides on top of HTTP. Okay? So HTTP is the base on top of which all the RESTful services are built. So there are 4 or 5 key verbs in HTTP which all of us are familiar with, right? The get, the put, the post, delete, and now we have patch as well. So REST heavily relies on these 4 or 5 verbs to basically take care of all the use cases, right? Whether you are creating a new resource on the server side, you are updating a resource, you are deleting a resource, that is where REST comes into picture. And all the resources on the server side, on the web, if you're using REST, every single resource needs to have a unique URI. It's called a uniform resource identifier, right? So every time you're writing a REST resource or you are trying to access a REST resource, most important thing is, what is the URI of my REST resource? Now let's step back and look at SOAP and compare it with REST. So SOAP is a predecessor to REST. Before people started using HTTP verbs per se, SOAP came into picture. I remember in one of my previous companies, we were trying very hard to be SOAP compliant. It was a mess. I mean, I'm talking about 10 plus protocols. Every damn thing had a protocol, WS transaction, WS security, and so on. And you even had a protocol to define the definition of your services, WSDL. Then there was a protocol, how will you discover resources, right? Or- and all of them, they were not seamlessly working with each other. So if I have a SOAP resource built using .NET, it won't get consumed so easily using Java client, and so on. So I remember they came out with a spec for all these specs to work together. It was a big mess. That is where REST was born. So REST said, let's take all this aside and let's focus on one important thing, which is all the resources are basically nothing but a URI on the web. I'm just going to use JSON to send data, receive data. That's it. You can also use XML, but JSON is lighter as compared to XML. XML is a little verbose. It's been around for a longer time. But what is the format of the payload you are going to send in HTTP or you are going to receive, that REST doesn't care. That is for you as an application developer, you have to figure it out, right? Or as a consumer of that resource, you need to know, hey, this is the resource. There is another thing called WADL. So WADL didn't take off that much, but there is an option for you to say that, okay, this is what my REST payload looks like. But we don't have a WADL in force.com, that is fine. Now let's go to the REST implementation of force.com. So REST resource in force.com is an abstraction of information or action such as a single data record or bunch of records, right? It could be a collection, it could be a single record. It's pretty much the same definition as compared to Roy Fielding's PhD thesis. So what this means, we are like a pure play REST API provider. And these are the 5 HTTP verbs we are supporting. So what are the characteristics of force.com REST APIs? Let me start from the top. The first and the foremost is it's stateless. So every request you make to a REST endpoint on force.com, it has to be encompassing all the information. Every new request you make doesn't know that there was a request made earlier than that. So what this means, if there was a request made earlier, you have to make sure you send the state from the client to the server. For example, if you have authenticated, you have an access token. So every time you make a request from client to server, you have to send that access token. So we'll see in demos how we are extracting the access token, putting it in the HTTP header, and sending it back when we have an authorized request. Now, how do we get this access token? That is where OAuth comes into picture. OAuth 2.0 is the standard protocol which is supported by REST. So there are 3 important flows. I'll not spend too much time. I have like 3 slides, but there are 3 flows for OAuth-based authentication. Then the next important thing is layered components. So all resources are name-based. For example, if you have to access SObject, so there is a SObject generic name, then you can attach an ID. If you want to get all the SObjects of a particular type, you just need to give an SObject name, and so on. Then it supports, the force.com REST API supports both XML as well as JSON. But I would advise using JSON. It's easier to parse, it's more modern, and you can compress both of them, but it's less verbose. So the amount of data with every request you are sending and getting the response is going to be lower. So we have friendly URLs. What this means, intuitive way of constructing REST APIs. So you can actually make, instead of making 2 calls, you can make nested calls within a single REST call, right? There could be like, if you have a parent-child relationship, you want to get the parent information as well as the child information, you can get both of them together in a single API call. And then there are some advanced things like e-tag and if match. So what is the e-tag? E-tag is basically a tag which you send in the header to first figure out, hey, did anything change in my resource on the server side? If it changed, then you send me the information, otherwise don't send anything. So you're basically trying to reduce the traffic which is going between the server side and the client side. And plus, if you have a very large payload, So it supports compression both for the request and the response. You can either do a compression either ways, or you can say, hey, I want gzip compressed files going, or the payload has to be gzipped and response has to be gzipped as well. So all this is supported out of the box. So let's look at 3 OAuth flows. So the OAuth supports 3 flows, and all these are supported by force.com. So the important thing to remember is the 3 URLs which I mentioned here in my slide. So the first URL is to get the token. The first step is you need to have the access token to make authenticated call. Once you have the access token, you have to basically see what is the authorization level of my client. And the third one is if you want to revoke the token. So now let's look at the first flow of OAuth. In the first flow of OAuth, what happens is it's called a web server flow. In this flow, you have basically built a web application. So this web application needs to go and access some information in Salesforce. So what you will do, the user logs in, and user is logging into a Salesforce from your web application. The page will jump to Salesforce page. So you have to program it this way that it does the redirection. So to that page, so the user logs in. You as a developer will never see the credentials. You will not see the username or the password. So once the Salesforce endpoint authenticates, okay, this is a valid user, you will get an authorization code. So once you get the authorization code, you will use this code to make another call to Salesforce. Hey, I got a code, please give me an access token. So then Salesforce will give you an access token and will also give you a refresh token, right? So what is the difference between access token and refresh token? Access token you can use, it has a time to live. It's called TTL. So TTL of access token also you can define when you are creating the connected app within Salesforce. So you can say, hey, it's like 1 day, 1 hour, 7 days, 30 days, whatever. As soon as the access token expires, you will use refresh token to get another access token. So that is the responsibility of you as a developer within your web application to get a new fresh token. So second flow is the user agent flow. So what happens in the user agent flow? In this flow is used when the client cannot securely keep access token or the authorization code. So from the client side, the screen goes to a Salesforce specific screen. Username is entered, password is entered, and the token comes back. So there is no authorization code, there is no refresh token. If it expires, user has to authenticate again. So this is user agent flow is generally used in mobile applications, and the previous one was basically used in web applications. Then there is a third flow, username password flow. This is the flow we are going to use today in our demos. So in this flow, what happens? You as an application developer have username, password, consumer secret, client ID, consumer ID, all those things. You just make a call, you get access token, and you're good. Okay? So this is different from other two flows. And when will you apply this particular use case? When you are making server-side to server-side call. So let's take an example. I have a Heroku app which is exposed to millions of customers. I have force.com data sitting behind firewall. But I know it's my Heroku app, so I can store my password and username there. So basically, it's a I would say a client about which I know. It's like basically authorized client. So he knows, I know I'm fine with this flow, because there is no way you can do user agent or web server flow in this kind of situation. So this is very important for a server to server kind of flow. Now there are like multiple ways of accessing force.com REST APIs. So as a developer, when you're testing, you'll use curl, right? Anybody, how many of you have used curl to access force.com? There you go. And Workbench is another very important tool, right? It is a PHP based tool, open source, which most of the developers are very comfortable using. But these are not the tools you are going to use in production, right? When you are doing a server to server call, even your mobile SDK based calls, you will have to use these APIs and you will have to use one of the languages, right? If you are using, if you have a Java based application, the only option you have is to use Java clients, right? If you have Scala, you'll use Scala. But you can actually use Scala with Java as well. Why? Because both of them are JVM based. Then there Python, Go, and so on. So now let's briefly look at curl. This is what a curl request will look like. Can anybody guess what flow is this? Which particular flow? Anyone? This is a username password flow. Because we have both these things together. If you see, you have a username, you have a password, you have a client secret, you have a client ID. And what you'll get is access token. So once you have the access token, what will you do? In the next call, you are basically saying, hey, get me details of this particular SObject. Now you can also create SObjects using force.com APIs, right? It's basically a complete CRUD use case. So the next call is about making a new account. So when you are making a new account, obviously you have to send the JSON which has the account details. So which will go in the HTTP body. So you have to add it in the body and send it. And this is a way of sending it in curl. So I'll not spend too much time on curl. Now let me switch to a more interesting part, which is the APIs. So the first API we are going to look at is Python. So the sample which I have written is based on Python 3.x, right? So Python has like 2.7 or 3.3 or 3.4. Now what are we doing here? First thing what we need to do is get the access token, right? So we are using the standard HTTP client API. If you look at the steps, what's happening? First we get the HTTPS connection. Remember, all the calls you are going to make in force.com are HTTPS, TLS compliant, okay? Now, first you make a request object, we make a post request object, then we make the call with the appropriate parameters, we get a response. Once we get a response, we have to extract the token. Once we get the token, then we use this token to make the actual call. So this is, if you go back, this was the method which I created, right, to get the token. Now in the next slide, the first line of the next slide, second box is the same method. So we are okay getting the access token. Now once we have the access token, we are creating a dictionary of headers fields. So what are the header fields? Two of them. One is the access token, second is the content type. Content type is very important, otherwise the force.com server side will get confused. Is it XML, JSON, what the hell is happening, right? Make sure you define both of them. You send the call. So when you're sending the call, look at the parameter called URL, right? So that depends on what kind of call you are making. If you are making a call to just get details of a particular SObject, your URL has to be constructed in a particular way. Now we are going to switch to a demo where you'll see how this is happening. So I have all my samples running in a virtual machine on my laptop. So this is the Python sample. So what we are going to do is, so we have created some util classes which allow you to, so that I can abstract out all the calls. Let's look at what is there in the util. So you guys are able to see the code? Yes? Okay. So let's look at the access token. Yeah. So this was the same code which you saw in my slide. This is the first call you will make, and the use case we are going to cover is we are going to actually run a SOQL query and from a force.com API client. So let's look at that query. So what does the query look like? I've put a breakpoint here. So I'm just getting list of all accounts in my organization. So I'm going to run this in the debug mode so that you can see what is happening behind the scenes. So I'm going to start this. It's going to go and stop here because I've put a breakpoint. Now let me go inside. This we can jump. Okay, my SOQL query has been formed. You can see this is what my SOQL query is. It's a string. Now the next thing is where I'm going to actually execute. Let me go inside that method. It goes in the util file which we just saw. So what's happening inside the util file? I'm going to first get the access token. Let's see what's happening inside the access token. It came to the same method which you saw in the slide. First we make a new connection. Now I'm going to make a request call. HTTP request call to do what? Get the access token. Okay? Okay, so you can see in the console something is happening. Okay, I've got the response. Let's see what the response looks like. Response is basically an object, HTTP response object. Now I've got the object, I need to extract the access token. Let me do that. So I've got the data. Can you see what the data looks like? It's basically a JSON string which has access token and the actual token. It has a key which is access underscore token and the value which is like the actual access token. Now I'm going to extract parse JSON and get the token. There you go. So I'm going to basically pass JSON back. Now I got the access token here. Can you see this? I've got my access token. Now I'm going to make the actual authorized call. So I created the access headers. You can see it's a dictionary of content type and the access token. Now let me make a get call. Internet is a little slow. Yes. So it has come back. Let us see what happened. Oops. Let me see what Wi-Fi I'm connected to. Streamforce. Let me run it again. So I think looks like we have Wi-Fi issues. Is there a Wi-Fi for the speaker? Is there a Wi-Fi for the speaker? Let me see if there is any other Wi-Fi I can connect to. There's a presenter Wi-Fi. Don't know the password. Okay, give me a second. So I'm going to use my phone to connect this. Okay, I'm connected. So let me go back and see what happens. Okay, so my phone is more reliable. So we got the JSON response. Okay, so you can see that, okay, I compiled and got a response. I extracted the response. Let us go back and look at the. So we are using another library called prediprint to, parse the JSON and do so on, do the actual parsing. Let us go back to the slides. Now, the next step is, sorry. So we just did a Python demo. Now let us look at the Java demo. So Java is a little more verbose language as compared to Python, right? In this case, we are going to use Apache HTTP client library. There are other HTTP client libraries you could use as well. Now Java has an inbuilt java.net client library as well. You could do that, but that's a little more painful to use as compared to the Apache client library. So I'm going to use the Apache client library. The first thing is that all my details about my client are stored in a configuration file. You don't want to hard code everything in your source code. Another important thing, if you are building any client which has to go into some kind of source control, make sure you never check in your actual credentials, because the whole world might be able to see it, right? So that's a security tip. And make sure you have a config sample file in GitHub, and every time you use it, you create another file which is a copy with a different name. So your actual credentials should never go into GitHub or any other Git SCM you are using. So in this case, what we are doing, the same access token method I have implemented. You can see the logic is almost the same. So we are using something called as HTTP client builder to create a HTTP client. Then we are instantiating the client. So we are making the post call to get the same access token. Once we have the access token, then we do the actual call. So let me switch again and show you how the Java call looks like. So this is my Java code. You can see it's very similar to, slightly different from Python. So I have created a generic object called SObject. Let us see what this looks like. Let's go to the implementation. This is my SObject. See, every SObject has a name. It needs to have a base URL on top of which it sits, and it has to have a host. The host is the organization or your custom domain name, right? So make sure you capture all this, and then you can make all the rest of the calls based on this. See, all this source code is available in GitHub. You can contact me, and I'll also share the link so you can go and clone and do your own stuff. Another important thing, the sample file I was talking about. So what I've done is whatever has gone into GitHub is basically the blank sample file. You can fill it up with your own credentials. So this is, once you filled it up, this is what it looks like. Now let us do a little bit of debugging and see what happens when I run the same SOQL call in Java. So first an SObject is created. It's like a object is instantiated. I know my SQL. Now I'm going to execute the SQL. Let's go inside this method, execute SQL. First I have to load the properties from the file. I'm not storing anything in the source code. I know, okay, my host is ap2.salesforce.com. This becomes the base URL. See, these are named resources. So every time you have to make a SOQL query, you have to send it to this particular URL, which has like version of the API / query and the actual query. Now we get the access token. Same thing to get the access token. Let's come out of this. Okay, I got the access token. Let us go back. Now it's going to print the access token, just as an FYI. Now I'll actually construct the real URL where the query is going to be made. So SOQL query, basically you have to replace the white spaces with plus signs, and nested queries are still not supported. So make sure there are no nested queries, there are no white spaces. All your white spaces have to be replaced by plus sign. So I'm sending the HTTP GET. So I created the HTTP GET object first. First you have to create a HTTP GET object in Apache client library. So you have to add the appropriate headers. So headers are again the same, which is the content type and the access token. Now I actually do the execution. So I got the response, which is my HTTP body. Now I'm going to parse and just show it. In this case, I said, okay, let me do a little bit more. I'm using a Google JSON library called JSON to actually do the parsing. I extracted the names and printed as a list. Okay, very simple demo, just to show you how easy it is to use the REST APIs. It's just that you should know which library to use, which endpoint to hit, how to get the token, and that's it. Now let me, while we are here, let me show you the Scala code. Same use case in Scala. So Scala is basically a less verbose implementation of Java, right? So let's run it. Very similar implementation. So here also we are getting the base URL. We are creating the SObject and getting the access token and then sending the actual response. Okay, so we got the response. In this case, I didn't parse the JSON, I'm a little lazy. But you can see that the important thing is we actually passed the SObject name, what we are going to get, and then we got the SOQL query for that particular SObject. Let me go back to my slides. This is the Scala code we saw. So one advantage with Scala which I have seen, even though it's not a very popular language in enterprise space, is that all the Java libraries can be used as such, right? So we are using the same Apache client library. I'm using the same JSON libraries. So this we have already covered. So you can understand the response, very similar logic. So with this we come towards the end of my presentation.